So, the EPTU, which was supposed to start today on the day of filming in this lovely Monday, has been moved to Wednesday, but that's not going to stop us from talking a little bit about what's included in it. The Vulkan API is a graphics API that allows for different kinds of stuff. I'm not going to try and get into detail about what that stuff is, okay? I'm not that smart, but I have watched a lot of videos on it, and so I can show you guys a couple of the videos that we have had on it. I can also show you a little update where Ali Brown, who is the guy who's kind of leading these efforts, talks a little bit more about it. Here is an explanation from 2021 CitizenCon, where they went over the Vulkan API additions they wanted to make to the game. DX11 and Vulkan are both APIs, application programming interfaces responsible for generating graphics in a video game. Depending on the graphics card, they can provide a noticeably different aesthetic experience, so it's crucial to recognize what they both offer. Are you wondering how the choice of API will impact your favorite game video performance? Let's learn more to see what the alternatives mean. Now, I'm not going to go through this whole thing for you, but the good thing to know is that this allows your software to interact differently with your hardware. And it has the changeover from DX11 to Vulkan, DX11 being, I think, the standard, I don't know who, is it Microsoft that created DX11? Yeah, DirectX 11. This is where the, DirectX is where the Xbox name comes from. It is a collection of application programming interfaces for handling tasks related to multimedia created by Microsoft. The biggest example I've seen of a efficiency boost from DX11 to Vulkan was Doom. I want to say Doom 2017, maybe? I can't even remember which one it was. 2016, I think. And the improvements were insane. Let's see if we can find in here. This is DX11, DX12. DX12 is another standard set by Microsoft. Not exactly what we're going to be using here, though. Here's DX11 versus Vulkan. Now, we can look at DX12 versus Vulkan, as is being mentioned in chat. You see, it's actually pretty comparable. The Vulkan's actually running a little bit slower here. But the idea being that it allows the hardware to work differently, and I believe, as he said, that Vulkan is much lower level in the code than DX11. I can't speak for DX12, but you have the choice of doing DX12 or Vulkan in terms of generational advances when it comes to these APIs. I think they're fairly similar, but I do believe Vulkan gives you still more control and more options for things like running on Linux and other stuff like that. All that being said, I'm going to go ahead and let the actual developers who are working on Star Citizen talk a little bit about this, and then we're going to look at what kind of phases of launching this technology they were supposed to go through, because it's been about 3-4 years since this video came out, and we have seen more and more progress on getting Vulkan into the game. You can choose it as an option right now, but currently they're supporting both DX11 and Vulkan, which obviously means more work for the devs. So here's what CIG had to say about this back in the day.
So what exactly is Vulkan? Well, Vulkan is a modern graphics API that allows us as developers to take greater control over what you as a player sees, and also affects performance greatly. As you know, we already have a few areas of bottlenecking on the CPU, but the design of Vulkan allows us to alleviate these bottlenecks by submitting work in parallel to the GPU. So I would like to explain a bit more about the software stack that's involved with our graphics in the engine. So from the image, you can see that we have a renderer front end, a renderer back end, and as well the graphics driver. The Vulkan API generally sits at the renderer back end and allows us a fine-grained control over what we develop and how we develop for it. It also gives us flexibility for cross-platform, including Windows and Linux, and anything we may want to look at in the future. The graphics driver stage is not managed by us, but we look at that and we gather information and process any crashes or any issues that might happen, and then we can deal with those further down the line. So you can see now how graphics APIs have changed over time. We're, of course, in the more modern section where Vulkan is on feature parity, essentially, with other APIs such as DirectX 12 Ultimate. You might also be wondering what a graphics API actually is, and we see that as a tool that is used for development that can interface between your graphics card as a player and us as developers so that we can give you the latest and greatest. Vulkan also has many features and extensions available to it that we will be exploring in the future, such as variable rate shading, bindless resources, and GPU accelerated ray tracing. To address any issues,
Yay, ray
we also
tracing.
need to collect data from our players' hardware so that we can use that to target specific features and extensions. We're not aware of any large-scale multiplayer games that captures Vulkan data live in the exact same way we do. Capturing this data allows us to plan ahead for any optimizations and then leverage that for the larger majority of players so we can bring you the latest and greatest. On screen at the moment is a diagram that shows the distribution available for Vulkan API versions amongst currently active players. This was captured in the last 3 months, and as can be seen, there is 98% of players that are able to use Vulkan fully in 1.2. We did see a negligible amount of 1.0 and some that were unavailable. We are actively looking into these cases, especially those that cannot currently run Vulkan as it is seen as unavailable. I'd like to take this opportunity to also say, please update your drivers, as we do see a few cases where this can take you straight to the latest version. I'd like to now explain a bit more about...
He's like, y'all, you've been running on the same drivers for 3 years. Please, God, save your computers.
The render graph and how this works hand in hand with the Vulkan API in order to improve our usage of Vulkan.
Okay, so that's an explanation. There's still plenty more in this. This whole video is very, say like dry. It's not boring. It's very good information. It's just, it can be hard to follow. But I'm going to jump forward now to Ali Brown, who kind of gives us a full-on update of how they wanted to roll this out. Again, remember, this is back in 2021.
So we've done a huge amount of work already. The architecture is all in place, and we're using this hybrid rendering approach where we're combining elements of the old and new render at the same time to allow us to move piecemeal to the new system. All of the post effects, fog, and lighting have been converted over, and they're all enabled by default in 3.15. And the fundamentals of scene and geometry rendering are all in place, but they're still being worked on. So our main focus is finishing that off at the moment, and once that's done, our focus will shift to the remaining major systems, which are gas clouds, the render to texture system, and a few special cases for transparency. After this, that's where we'll start seeing the public milestones, and the first of that will be 100% usage of Gen 12 and none of the hybrid approach. This will still be at DirectX 11, our current graphics API at this point. And then our second milestone will...
So that's, I believe we were on that for a while. I don't remember when they actually started doing that, but that was a couple years ago. It's actually, I think it's on the roadmap. Let's open the roadmap real quick. Let's see, 3.18 might have had that. Yeah, Gen 12 scene rendering was in 3.18. So new rendering architecture to improve performance. This milestone renders every scene object through the new renderer with optimizations and additional features such as Vulkan coming in the future. So this was with Gen 12, DirectX 11. I don't know if they had put the other... Yeah, and here we go, 3.23. This was last year. Converting the Star Citizen renderer from DirectX 11 to the Vulkan graphics API. This allows spreading GPU submission work over many CPU cores and enables many new tech features that were previously unavailable, such as ray tracing. Vulkan is able to be opted into via the options menu with this release, but it will eventually fully replace DirectX 11 in the future. So that's what we've been on since early last year. That is this milestone 2, I believe.
Will be the Vulkan API release, That will be optional at first and then mandatory after we've removed all the bugs. And then a final milestone.
And so right now, I'm guessing they're getting that sort of mandatory. It's still not mandatory. You can still choose between the two.
So will be when we have performed the optimizations for multi-threaded. So that will only happen once the Vulkan is in place and we can finally look at the performance on the final graphics API and optimize all of the remaining code.
So this work that they might be doing might just be that next step in forcing Vulkan to be the standard that everyone uses. But what we have been looking for has been the support for multi-threading on the CPU, which allows them to obviously spread out the work across CPU cores a lot more, but also, as has been mentioned when it comes to Planet Tech a lot, allowing them to use the GPU for a lot more of this work. Now he's going to talk a little bit more about what this will enable across the game too.
So after Gen 12, I just briefly wanted to touch on what comes next for the graphics team. So a lot of Gen 12 has been focused on CPU performance. So after Gen 12, we really want to start looking at the GPU performance. The first few things we'd look at here were things that wouldn't change the visuals, just improve the frame rate. Things like DLSS, FSR, async compute, and variable rate shading. After we've type of improved this GPU performance, we want to start looking at some of the more exciting visual features. So then there is also mesh shaders and primitive shaders, which is technology we can use to generate procedural geometry. And this type of thing could be really exciting for things like the planets or asteroid fields where procedural geometry is critical. And then there's the big one, ray tracing. We're very excited to get onto ray tracing, especially to use it for lighting, such as global illumination, but also reflections and shadow quality. There's a lot of exciting areas for us to look into, and we can't wait to get into it. So that's it.
Right.
I just wanted to say a big thanks to everyone who's been involved in this technology. It's involved the graphics team, engine team, VFX, and Planet Tech all working together on a huge piece of code. And we can't wait to get into your hands as soon as possible.
Thanks, Ali. Now we can jump over to CitizenCon, where they actually talked about this on stage. So a lot of what they talked about in this was a lot of the Planet Tech kind of revolves around this.
Framework so that we can run it at both and swap. And now it can run on many cores. This allows it to be run perfectly well on both the CPU and the GPU. So we've redesigned our framework so that we can run it at both and swap between them freely. Now, the benefit of this is we can do things like, first off, move the terrain system to the GPU, and we've now done that to get some incredible performance improvements, but we then also cache the results in something we call a virtual terrain texture. I'll give you a quick demo of this now. This is now vastly faster than the previous system, but it also allows us to generate the terrain in much higher resolution, which means all the popping you can see on the mountains as we're approaching, all of that should be completely eliminated on the right-hand side of the screen.
Yeah! So this is like really just putting pictures and videos to the performance improvements that this kind of stuff will allow. Not to say that this is all because of Vulkan or anything, but a lot of this work, the GPU object scattering, the usage of the GPU for all this kind of stuff is sort of trapped behind that move to Vulkan.
With the terrain data cached on the GPU, like Ali said, we can perform the scattering there too, which is significantly faster. All those algorithms that we've used to generate those first bits can run there without being more expensive on your CPU. And it also means the results are directly there on the GPU. We can render straight from them.
Now, the other side of this is the other stuff that they talked about, which is things like global illumination, ray tracing, reflection.
Forest as you'd see it without the GI system. As you can see, all the shadows are receiving lighting from the same environment probe, so it's basically just a flat color across. We replace that with around 40,000 mini ray trace probes. Each of them has their own view of the sky, and so that gives you way more contrast and variation as you move in and out of the canopy.
But more.
To do it. And the challenge here, though, is that the ray trace reflections you're going to do, they're not just mirrors. Like, we've got a whole range of objects in the game, from like a scuffed hull panel all the way up to chrome polished pipes.
Yeah, there's your MISC ships, Star Mage.
Across that. So I'm going to do an uncomfortably short breakdown on what this tech looks like and how that comes together. So here's what we need to beat. Now, obviously, it reads as shiny, but there's this kind of fakeness to it. It kind of looks a bit like it's flying. So let's see what the ray tracing looks like. Yeah, it's really noisy and horrible. We need to clean it up. So what we do is we let pixels share their data in space, and then also in time to clear up the final image. And then we let the game's normal anti-aliasing just kind of clean up the last stuff and carry us over the finish line. And that's how you make a Chrome Penguin.
Chrome Penguin. So that's just kind of an overview of how Vulkan is expected to be utilized here and how they are hoping it will allow them to make the game not only more efficient, but also more pretty to look at. Now, here is a recent update from the forums of Star Citizen, where somebody asked about Vulkan, what's going on with it, and Ali Brown, same guy that we just saw, he actually answered some of their questions to let us know kind of where we were in the progress. This was about a month ago, July 7th. So the user asked, for users currently affected by performance and compatibility limitations, it would be valuable to know the current development status of full Vulkan integration. The implementation of all Vulkan features could significantly improve overall stability and reduce noticeable stuttering in the game. I assume we may not see this transition until after the release of Squadron 42, as it's likely that its single-player framework is already taking advantage of Vulkan, offering a more optimized experience than we currently have in the persistent universe. I would imagine so. So let's see what Ali Brown had to say to this. So he says, following on from my previous message on this topic, helpfully posted by Dr. Phoebus below. Why don't we check that one out first then? Where is Dr. Phoebus? Okay, here's what he said previously in February. The focus for Star Citizen recently on the code side has been on stability and quality of life improvements to existing features, especially after the rollout of server meshing and the huge impact it's had on the game. As a result, the Star Citizen team haven't been able to take full new version of the engine in a while. This is something that has come up time and time again, and is actually could be a big deal for this game. As a result, the Star Citizen team haven't been able to take a full new version of the engine in a while, because this would bring potentially instability and slow down the quality of life improvements for players, and also likely prevent regular timely releases, all of which are critical for continued engagement. Big tell right there. Continued engagement has been their top priority this year, and for that reason, they have specifically not launched new versions of Star Citizen. They have stayed on the same code base for the entire year, which has blocked them from inputting new features, blocked them from creating new optimizations, and doing different things with the code that they would need to actually have a new code base for. So, and this is something that good friend and lovely member in the chat, Certified Gumbo, pointed out to me. A lot of features might just be being made to work with Vulkan specifically, and therefore they're not putting them in because they don't want to have to create different versions of the features that might work on DX11 or on Vulkan. That's kind of being corroborated here. A lot of people will say there haven't been bug fixes, there hasn't been anything that proves that they're actually caring about performance or stability, but the fact that they're not pushing new versions of the game is partially them trying not to do things that break performance and stability. Continuing on this message, he said, the Squadron 42 team have been road testing Vulkan along with HDR and multi-threading rendering, so hopefully most of the kinks are ironed out by the time they reach Star Citizen, though I won't be able to predict when exactly that will be. Yeah, dude. Hell yeah. So now we can look at what Ali Brown's newest update is. He said, in July, we've been integrating the latest renderer and other tech from Squadron 42 over to Star Citizen's main branch and about to begin testing and bug fixing. But don't get too excited just yet, it can take quite some time to get to the patch stream. And then an actual public release, all depends on how successful the testing is. This will include major changes to Vulkan, some upscaling changes, and both CPU and GPU optimizations, though some larger optimizations will come slightly later. Global Illumination will unfortunately not be included as that needs more optimization and is missing a few features for Star Citizen that Squadron didn't need. So this isn't Global Illumination coming in, but we should be seeing some CPU and GPU optimizations, which is nice, and possibly some upscaling changes, maybe with DLSS, FSR, and TSG? Something? I don't remember what CIG's version of that is. All right. Next update he gave after that was just asking somebody asked to expand on the tint system. The tint system is what allows us to recolor assets and swap out decals from a library of tint palettes. It's used as part of the skin or paint system for vehicles and items, but is also used more extensively in environments to allow much greater reuse of assets and keep color themes consistent across many assets. Each tint palette defines a primary, secondary, and tertiary color, gloss, and specularity values for each, a set of 3 logo decal masks with 3 associated colors and a glass color. Artists can set up hierarchies of tint palettes such that a whole building can be assigned a hierarchical tint palette that will correctly assign individual tint palettes to each separate element. That is not the easiest sentence to read. The GI system obviously needs to understand the color of the walls to be able to correctly bounce light, and for the most part, it already does. But in some cases, the system falls back to cube maps. These cube maps have geometry and materials baked in, and this is part that doesn't currently support tints. So the tint system is reflections, global illumination, stuff that can allow for ray tracing, and that is obviously, from what I'm getting from this, it's just, that's hard. It's difficult. So can't give you more on that, guys, but these are words straight from his mouth, or I guess from his fingers. Take of it what you will. He continued down here to give a little bit more of a response on DLSS and on Vulkan optimization. He said, I can't really advise on the specific crashes on Vulkan and Star Citizen right now because they are mostly reported as general GPU or driver crashes with no clear cause until further investigation. The code you're running is over a year old, and we've changed over a freaking year old. I guess it's basically the same stuff that we got from Alpha 3.23. We've changed so much in the main branch in that time, including many such GPU crash fixes, but also the addition of various GPU error reporting systems. So I'd hope these issues will be resolved, and we're not aware of any issues with specific hardware with our internal testing, but that's a tiny sample size versus the public. So if we do find such an issue, there would likely be a point patch to resolve it, with DX11 still being available. Regarding visual issues with DLSS 4, there is a very little control a developer has over this. We provide basic information about the scene, but DLSS has no specific game-provided knowledge about fog or transparency, so that's generally nothing we can do. Besides that, I think that first response he gave was really the most important one, and that was just helping us understand where they are in terms of doing this. And he did mention here that they were going to move over the stuff coming from Squadron 42 into Star Citizen's main branch to begin bug fixing and testing, and that is what is going to happen in the EPTU this week. Thank you, it's TSR, you're right. So we're moving along. This is not the end of the road for optimization or graphics in any way, and this is not necessarily going to introduce anything like global illumination or ray tracing. This is more getting the game updated to whatever their main thread was last year, getting it closer to feature parity with Squadron 42, and sounds like most definitely setting it up for the optimizations they need in order to do things like Planetech V5 and possibly some other things that are only being tested on Vulkan and not trying to see parity in development between DX11 and Vulkan, which could cause a lot of trouble. Does that mean that with this, we're going to start to see a lot more features come into the game? Not necessarily, but it could. Stay tuned, and we'll dive deeper into this after we get some results from this week's tests, but it sounds like because it was delayed, it's still a little rough. So we'll see next week.